All right. So, in order to get, so this uses this AWS Wrangler library. You can, look at it on GitHub. It has extensive documentation. This is the same thing where it says software development kit for pandas. That this is the same tool. All right. And it looks like, I think it is like an official AWS library. Now, in terms of how it works, what you'll need to do is make sure that your credentials, your AWS credentials, are in there, are basically in your environment. Remember, you can type like AWS configure to make sure, right? And that will bring up your access key ID, all right, and then your secret. If you don't have this configured, if you don't, already have it configured, you'll get an error when you try to use it, and it'll tell you you don't have it. And what you have to do is go to AWS, create a new user, give yourself probably admin access, give that user admin access, and then get the API keys. And it's in the reading as to how to do that. But you want to I would suggest giving admin access because it's not just for S3 that we'll use this for, but also Athena and Glue. So it would just make sense at that point to do that. So I should have it, right? So what I'm doing is I'm reading data, from S3, chicagocrimes.csv. What you may have to do is go to, download this on download this and upload it to a bucket, or you can just use any CSV file that you have in a bucket. It works fine. But you can see, what we're doing is this WR, so that's Wrangler, .s3, read CSV, and then just specifying the path, okay? The low memory equals false is because if it runs, otherwise it's more likely to run out of memory. And then I'm specifying the index column, just like you would with pandas, right? That the first column is the index column. And then once you read this in, you can see it's taking a while. This is a large data set. You can then save this file. All right, so it works similarly. Oh, look, we finally have it. So I read it. It's just a data frame. So by the time we get it, it's returning to us a pandas data frame object. And then you can save this data frame object, right, to S3 by using Wrangler. And the way that you can do that is you just specify the path, right, the file that you want to use. So here I'm doing the same bucket, and then I'm doing this might be confusing, I'm doing crimes.snappy.parquet, and you can see I'm doing s3.toParquet, all right? So, so this is, we could save it as CSV. We're choosing to save it as a Parquet object. There's a couple reasons why. One, it will store it column-based. So if you hook it up to Athena, right, it can query by column, which eventually we will do, hook it up to Athena. So you get the same benefits, right? We generally care about analytical queries, which is single column as opposed to a row. Compression, so the storage cost will be lower. In these cases we might be storing a lot of data. So by doing this .snappy is the compression algorithm that it's using. All right. So the storage costs will be lower. And then the other thing, this is actually very valuable, is that CSV does not store data types, but Parquet files do. All right. So when we read this down, we would have the data types stored as long as we when we do the two Parquet, as long as the data frame is already we've already coerced set some of the data types. When we then save it to the Parquet file, it will maintain those data types for us, right? Which is very valuable. Same thing, if we eventually, which we will do, have Glue crawl our S3 file or S3 bucket, it will automatically set those data types that it sees stored in S3. Okay, so right, just by simply doing that toParquet method, we get these benefits. All right, it takes less space, column-based, and it stores the data types. Oftentimes, what you'll do is treat multiple files as a single directory, and this is not hard to do. All we're doing here is we're going to do that same method to Parquet, but the only difference is instead of specifying the direct file name, we're just specifying a path, right? The bucket name and then the folder name. Okay? And then the last thing is dataset equals true. Dataset equals true means treat all the files in the folder as a single dataset. Okay, so here I'll actually run this. We can see that it saved this. It's giving me the full file name that it did save it as. And then I'm going to save the last set of crimes. So you can see each one of them, this has the first 100, this has the second 100. So I'll save the second one. And now when I read from this, I'm going to read the entire folder. Right, breaking. Let's see what it says. Unable to merge. Oh, I must have messed something up where maybe the two data sets, this doesn't make total sense, have different, maybe the two data sets have different data types and now it's breaking. But in theory and before this lecture, you can read this, right? Read the files in the path, and then it gave me a combined data frame. Okay, so basically I'm just treating the contents of the folder, even though they're in separate files, as a single data set. All right, and it works fine. Let's see if I can delete the objects. Here I'm deleting it. Let's write it again. So we'll do, I have these first crimes. We'll save that there. And then we have the second set of ones. Okay, so this one's saved to this file, 936. And this one's saved to a separate file, 28203. And they're both saved to this same folder. And now I'm going to read the Parquet file, Parquet files from that folder. Set dataset equals true, and that seemed to have worked fine. So now this is stored as my crimes df, and you can see that we have all 200 of the rows, right? So it's merged. And then if I want to delete, the contents of the folder, I can just call wr s3 delete the objects. All right. So this is how to get up and running. It's pretty straightforward. Oftentimes you'll want to partition the columns. We can talk about kind of why. But for instance, let's say we want to partition by year. What we mean by this is, well, first of all, to do it, you just pass through this argument, partition columns equals the year, and you specify the column name. And then you can see that this is now, take a look at this, Chicago year 2012, Chicago year 2015, Chicago year 2016, right? So it's adding these subfolders where it's storing the files now, okay? And what's the benefit of that, right? The benefit is if I want to search for crimes of where the year equals 2016, right? I can do that. And it will only search, it will first scan through, find this folder, and then only read the contents of this directory to do that, okay? So instead of searching through all the records in every folder, which is basically what it would have to look through all the records if we were not using partitioning. In this case, it's just looking for, reading the file from this folder. If we say select, find those in this year 2016. What can take advantage of partitioning? How do we actually use this in a query? Athena, okay, Athena, PySpark, those kinds of tools. So. So let's see that. In order to use Athena, this is the interface for Glue, wr.catalog, and that will list, you'll see we can list our existing databases with that. So I did this, Chicago datasets one. Let's see if I can recreate it. Otherwise I can probably delete the database. Let's delete the database. wr.catalog.delete database, Chicago datasets. So that deleted it. If I look at the datasets again, we can see it's gone, right? And now we'll create the database. Okay, and that database does not have, so you can see that it's there now. And now this data set doesn't have, a table, or there's no columns in the table. So that's the next thing. The next thing is basically to run our glue crawler, right? To crawl over this data set, what's stored in the folder, and to add the contents to a new table called crimes. Okay, this overwrite means if there's already a table there, that where we specified the schema, we are overwriting it now. Okay, so we'll do this WRS3 store Parquet metadata. It's storing the metadata in glue. All right, so now I press return here, and now if I query for the catalog, right, this glue catalog, the table crimes in the database of Chicago data sets, you can see that it's pulling down the columns, right? This is from our data frame, basically, from what was stored in S3. And let me see if we can show you it any better. Okay. The other thing I wanted to show you is it's getting the correct data types, right? Doubles are a kind of integer. So not too many of these are integers. So how did that work? The way that it got the correct data types, remember, is that you have to make sure that the data frame itself has the correct data type. Then when you save it to Parquet, Parquet will save that data type, right, in the S3 files. And then when Athena finally reads from it, right, it's going to detect those data types and save it in the glue, store that metadata in glue. And then finally you can query it. Okay? So here we're using, again, Wrangler.Athena read SQL query, select all from crimes where the year is 2015 or is over 2015. It is giving me an error. I wonder why. It says mismatch, cannot apply operator double on varchar. So, this is kind of interesting. So I think it did. So basically it's complaining that this is a double and this is a varchar. So I should just change this to a number. For whatever reason beforehand, it wasn't actually saving this as an integer, but now it seems to be doing that fine. So this time it worked, right? So I'm saying all from crimes where the year is greater than 2015, and it queries them fine. Okay. So this is kind of like a pretty good, workflow, right? We're able to basically just take our data. We could hit an API and pull it down. However, store it in S3, partition the data, right? And then we just one time have to run the glue crawler, and then we can query it with Athena. Okay? So the readings just take you through that. The only other thing, it's not here. I put it in a Word document. To talk through is like choosing a partition strategy. For that, the main thing, right, is access pattern. By access pattern, we mean what are you going to be filtering by? Which column are you going to be filtering by? All right, because that's how these query engines can take advantage of partitioning. So if you're not filtering by that year column, you shouldn't use it as your partition strategy. It's not going to help you out. And the other thing is, just remember, partitioning basically just means putting things into folders. So if you think about like how you organize folders in your computer, it's a similar strategy. If you have a folder for every document, that makes no sense, because you're just gonna have to go, instead of searching through a bunch of files, you're just gonna have to search through a bunch of folders and click on every one, right? So you want to like kind of have maybe kind of evenly space out files per directory, and maybe you have like 100 per each. Well, here you'll have more, but the point is like you don't want too many, because then you're just gonna have to search through every folder, and you don't want too few either, because say you only have 3 folders for all the documents in your computer, then you just click on one of them and you're still left searching through a bunch of data. So it's the same thing. You can do trial and error to figure out what works, and then there are rules of thumb based on the database you can Google that. I don't have them off the top of my head, but it's like a certain amount of gigabytes are ideal. The other thing to consider is just data skew. So the example I give here is like you probably don't want to partition by last name, right? Because or last name's letter, right? Or we could say last name. Why? Because like the name Smith is going to have a bunch, right? Or if we do letter, like A would be common. But while Z is very uncommon. And so every time you get somebody with a letter A, which is going to happen pretty often, they're still searching through a gigantic folder, right? Whereas Z, like, yeah, that rarely happens and it's very easy. So you want to worry about like that each of these folders has a relatively even partition of data. And what's like a good criteria for that is the date column oftentimes works, right? Because like every day you get new records, but just consider that it's not date time, because date time, like you don't want every second to have a new folder, right? So you just want to think about that. And then I get into partition explosion, which sounds worse than it is, but it's just like that each partition has metadata associated with it. So that's another danger of having too many partitions. All right. So that's that. Then there's this AWS lab. And then finally, I can talk about kind of projects. Let me talk about projects briefly. I think the main point is just that, I have this advice on on choosing a project topic. And I think the main thing I would say is it's very important to choose like kind of a worthy project topic. And it's okay to spend some time on that, because even if you have not, like, say, part of the reason that we're doing projects is they're a good networking tool, right? They're a good way for you to, like, call people and ask questions and, have something to talk about, like, and follow up, etc., right, as you work through your project. And your project doesn't need to be finished or even, like, viewable to somebody yet for you to have good questions about it, right? And for you to have a reason to talk to them on the phone. But if you just have, like, like the typical project of, say, like, see how well Twitter comments predict stock prices. Well, there's not much to say about that, like that's only gonna take you so far in terms of like a conversation or spark something. So I gave a bunch of resources here of like the McKinsey reports, ProPublica and their related GitHub code, Urban Institute, this other news journalism, Pudding.cool, The Economist, right? Like you can basically take any of these topics if you want, probably, and just reproduce them and add more data engineering, because they probably did not put the work that you guys can do in a data engineering project. So like these things are pretty good topics, and what's good about them is they're specific. Like they're not like they're more specific than just like I'm curious about, right, music. It's, well, how does music affect mood throughout different countries, right? If it's The Economist. So that's my main advice. And then, we can kind of get on from there. The second piece of advice is, after you kind of feel like you have, as you're kind of researching this project, see what has already been done. Because if someone else has already done it, it doesn't mean you cannot do it. It's fine for you to redo it. If, say, a few people have done it, but they will show you what the end product can look like before you even get there. So looking at what they've done will help you refine your own project. It will show you what data visualizations can look like that will be effective. It will show you what data sets can be good. So spend some time, typing in your project name /GitHub or Kaggle to find similar types of work, right? That's the main advice I have. And then for the tech stack, you can alter it, but what I recommend is like Python Prefect, DBT, right? Use DBT Core, and then connect it to like a Streamlit, Flask Streamlit app. I have some curriculum on Streamlit. It's very similar to Plotly, but it's like more interactive. You can deploy it. All right, and that's it. And like I said, you don't have to, like, as long as you're choosing a project that you're interested in and that is interesting, and we can happy to give you feedback on that. Like it takes years for people to finish, like finally release their startup and launch, right? And trust me, if they're doing it right, they're talking to people all along the way, right? And having interesting conversations. So that's what I'd recommend. All right, so that's it about kind of projects. We can talk more about it. Then there's one last thing, which is you should have received an invite to Hunter. Okay, so this is really important. We'll talk about this more than once. But Hunter is like a job tracking tool, which will make it easier than you guys just, I feel like it was probably pretty tedious to copy and paste jobs that you applied into the Google spreadsheet. So let me show you how like easy this is. So I have this job search 2023, and these are jobs that I applied to. Not really, but you can imagine applying to. And then if you just go, let's say we want to search for a job, so type lever.co data engineer, and then one. And then we click here, right? All I have to do is, I've downloaded a Chrome extension, which I put in the Slack channel. I just have to click Save to Board, and then it already has filled out this information for me. And then I click Save, and now it's in there. Okay, that's it. Okay, so this is how we can keep track that, like, right, you're hitting the goals in terms of applying to 25 per week, right? Like, you want to reach out to 10 to 12 of them, like try to connect with the hiring manager of those that are interesting for you. But it was also like, it's going to help us figure out what's working for you guys individually and then also as a group. And it's not just me doing this either. It's me, Yu Chen, Wayne. We may like bring in some other people as well. So like, it's okay if you kind of tell me, but I might not be the main person kind of assigned to you, right? To like help out and make sure that you're managing your funnel properly. Okay. So you should have received an invite to your email address for Hunter. Sign up for that. The other thing is, in Hunter, you can see that there's this profile. It's the same. It's very similar to Simplify Jobs. It's the same type of thing. But if you fill it out, then not only can you kind of do the same thing where it will quickly apply for you, but me or like a career coach can also actually just like have your name, and then I'll fill in your information, and basically like, I don't know if we'll actually do that, but like we can see if it's a fit for you all, but it would actually send the application in for you, if that's something that made sense. So this has a bunch of features, but that's the main one is, right, it allows you to keep track of your funnel, allows us to like see how it's going, and like actually see what's working, what's not working. So one thing, for example, like talking to the people at Hunter, like where people list jobs, obviously it's good. It's like we get directly to the hiring manager, etc. Another good tool, right, kind of like I mentioned, is just, and this is good because all of you kind of have prior careers, right? So you can kind of see, right, like so Zili worked a lot with like cancer data, so he has like a bio background. So so what I did was I just typed in greenhouse.io, cancer, and then data, right? The reason why is because it could be data analyst, it could be data engineer, data scientist, right? I don't know, like any of them are probably fairly relevant. And then you can scroll through, right? And a lot of these are fairly relevant, right? For some of you, it's been like healthcare data. And do the same thing, so you can see a lot health data analytics. So it's like you all have specific backgrounds, so finding things that really line up can be quite good. Then from there, the other thing, I forget the name of the company we did. Give me 1 second. In terms of finding the hiring manager, let's see. So I did this with one pair. You can see, so we had this like 0.72. It's like, how do we find the hiring manager from here? It's not listed. So there's, so LinkedIn is kind of like an obvious approach. It's kind of, it's what I would do first is just go to LinkedIn, type in the name of the company, 0.72, click on it, type in people, right? And now I'm just looking for data engineers, data scientists, things like that. You can search, right? And I can type in data engineer. When it's this large a company, like the LinkedIn search is not always great. Like these are data engineers, but I don't know if they're exactly the right person. So instead, the next approach, and especially because it's such a large team, I'm not, you're not quite sure. The next approach is just do point 72, and then do data engineer manager, right? And now here, so this guy, there was like a blog post, and then I don't know, maybe it was data engineering manager. Yeah, this guy. And then this guy as well. All right. So you can see that he's manager data engineering at point 72. And this is probably a good. And the other thing is he's located in New York, which is also where the job was listed. Right. So now this is pretty good. I'd also look along this side here to see other relevant people, right? So you can see this guy's a manager as well. I might look at his profile. The CFO for a smaller company, meaning like 50 to maybe 100 people. If it's a 100-person company, then they probably only have like 30 to 40 engineers. So at that point, right, the CFO is probably still involved. Like, what does that mean? They have like a few hires every quarter, right? The CFO is going to be, or CTO, I mean, would be involved with that. But for a larger company like this size, the CTO, if we found him, would be too senior to reach out. But these guys would be good. So, we found this guy. This guy here looks quite good. And then I would certainly, even if this is old and he's not relevant, I would read through this entire thing and like look at what this guy was up to as well, just to get more context on what does this job entail? What is this thing about, right? And then of course I do the standard research of looking to see, okay, point 72, do they have a GitHub, right? Do they have a engineering blog where I can learn more about the stack? So they do have a GitHub. It's not useful. But I would just want to like learn more about the stack. And maybe you can even go. I worked at Point 72, so you could even go to like some of their employees' GitHubs, because sometimes you'll see related projects and learn more about it there. And the point of this is that when I then send out like my reach out email, it should be like a pointed question. It oftentimes will come through that you're not just asking a question that's right on their website and you should have researched, right? Right, you're kind of showing that you've done this extra degree of research. Okay, so that's basically how I would find the hiring manager and also just like find good jobs. And then, like I said, when you're choosing the project, you're going to want something like it has to be something you're interested in, but ideally it's something that's kind of in a domain that you can see yourself working in, because it's like one other thing you can talk about, right, when you're talking about reaching out to these senior people. And then finally, so next class, what we'll do is look at the project. We'll take a deeper look at that project that I looked through, and I would also say like, use those resources I mentioned about finding, in order to find a pointed project. And the other thing I would say to do is, use ChatGPT. I was doing this with Polly. He wanted to research kind of like, education data. So I just asked ChatGPT, is there education data that we can get through APIs? And it listed a lot of them, right? Coursera, Khan Academy, Udemy, right? There's higher, Europana. Is there any good data journalism, right? So I'm trying to find similar kinds of studies on education or reports that are data driven. So I think this is another good type of question, right? Like, because then it shows me ProPublica generally does this. Here's an example of miseducation, right? And now you can see like this is pretty interesting, right? It probably has the data set down here too. And then a final thing is like books. Like if you're gonna spend a little while on this, it's not bad to like see if you can find a data-driven like book on the topic for $10. And like I think I'm amazed that like I think books can like I'm advocating for books. I think that books like really can just provide you information that you're just not gonna get like all the time on the internet. And so then just like they'll reference reports or other things that then you can like look at, and that you'd be amazed just like how much further that will take you than just like the standard research. All right, that would already put you a leg up, I would say. All right, so that's my advice. Final thing is, if you have not signed up for Hunter,